and for our organization. You see, our organization right now focus on robots. See, so also I will comment that all we need to talk about is this one subject, robot, which involve everything. Like just our friends just say that. The question is how to build a robot which can replace all human physical and routine works. If we can do that, and what robot to build will be determined by the solution value. Okay, the whole world is approaching us, actually. I don't need to promote this. First, the Nobel Prize in Physiology, where actually they are just explaining how do humans feel, but they keep talking about touch. They think this is solution of touch. Okay, that is I think this is way too simplified. you know, Conclusion. And also driverless cars. Okay, driverless cars, they try to avoid things. I wrote an article, I say that driverless cars are for the birds and fishes. They try to avoid things when they flying around. But for humans, and also animal, insect, the most important thing is contact. It's collision. It's not avoiding collision. Okay. Finally, the robot, we see lots of rockets landing and docking. Okay. This is really something that is embarrassing because the landing is very clumsy. There's no touch. Okay, it just come down, straight from a parachute. So basically, our organization, Pole Science Institute, feel there's no robot today. Okay. The reason is a robot is an intelligent machine which can safely come into contact with an uncontrolled environment. So it should survive completely autonomously. And there is the problem of touch is a 300-year-old problem. It's called the contact problem. Newton couldn't solve it, Hooke couldn't solve it, and now we are addressing it. So what really amount to is the society need to become as intelligent as Dai Wu, who is the Chinese father of physics, in thinking about this solution of touch. And they also need to go into artificial software. John von Neumann, C.V. Ramusi, they need the complete automated software in order to have sensors which match the human ability to sense. Finally, the most difficult is fuzzy logic. Okay, you can never be precise in touch. You have to define the range of tolerance of the, both of the timing and also of the jumpulse, the force you apply in touch. So my feeling is this project for this problem for the society, it's not even started yet. They don't even understand the problem. Okay. Right now, Pole Science Institute is trying to define the problem in its entirety, what it takes to build a robot, general purpose robot with the ability of touch. So what I'm suggesting is we have a double hitting test, where I call it simply Ching Test, my test, which versus Turing Test. Turing Test is really not serious. It tests the common sense of a computer. It doesn't really make, it's kind of just a not serious test. But this robot test for double hitting, you build a robot which can double hit. First, it must see where the ball is. Then let's move over to it and apply a jumpulse. Okay, timing, precise timing, almost precise timing. You have to figure all the range of tolerance of the sense, of the physical motion. And also you have to have some kind of seeing with the mind. You do not see it with senses. Okay, this guy got Nobel Prize, he thinks the sense is most important. Sense is just part of it. Even the sense requires fuzzy logic to tell them what is the range of tolerance for feeling this at the sufficient time for you to react. In touch, it's not possible. Okay, once you touch, the time involved in touch is much shorter than the science to react to touch, to the feeling. So basically, I'm just this is the subject. I will encourage you to continue to talk about this one subject. It's enough. It got everything. You see. And unfortunately, today we don't have a robot. They all think they have a robot, but I don't think there's too. Also, I think there are too many hurdles for them to overcome. They got to be as smart as Dai Wu, as smart as John von Neumann, von Morsi, in software, and they got to understand law of disadvantage, father of fuzzy logic. So basically, this is it is the central question. Okay, and also you asked me about all this safety situation. This is,
Yes.
It's kind of funny. I suggest once I jokingly suggest that people should fight their wars in space, robotic wars in space, to see who can win. Don't try to fight where there's humans. And this is a social science which is not as difficult as life science, but I would say when robots start to fight a war, it's a totally different situation. My feeling is that politicians were afraid to fight any wars, except against some enemy which have no way to fight back. Otherwise, this robot war is a huge threat to the human population, and it's so big a threat. It probably will stop wars. It's probably more threatening than atomic bombs. So basically, my feeling is we should continue to talk this project, and there's altogether 3 areas: the physics of touch, artificial intelligence, which is required to sense where the ball is, how to touch it, where's object you have to touch it. And finally, the most difficult is fuzzy logic. You see, fuzzy logic, law of disadvantage actually is trying to dismantle science, dismantle physics, because physics is about precision. Okay, here, law of disadvantage come out to say that there's no such thing as precision. So, and I'm in the process of applying for my student nominated for awards all over the world. And I think, the foundation of knowledge should be fuzzy logic, replacing exact logic. So that would dismantle physics. And the consequence of this fuzzy logic is before fuzzy logic, no solution is valid because Kurt Gödel think logic is incomplete. Kenneth Arrow thinks that logic is inconsistent. So no solution valid before fuzzy logic. After fuzzy logic, all the solution becomes valid as long as you define the range of tolerance of the solution. Okay. Okay, let's go back to the situation with the current knowledge society. Okay, what is happening is human being has science. Okay, so we try to make all subjects sort of following science. Okay, so science has been applied to military, it's been applied to business, applied to computer science. But I would say the only successful application of science is into military. Okay, the business, we have financial crisis nobody can solve. I know they cannot succeed. Also in software, it's a partially automated software. The computer itself it's a dangerous. It's produce all this software which has to be manually maintained. Okay, and now we have to go back to science. How do you make robotics scientific? Robotics is not even scientific. Okay, so my suggestion is to go try to solve this problem which has been with us for 300 years. 300 years ago, Isaac Newton and Robert Hooke had a debate on this problem of contact. You know, if you want to push something, you have to make contact first. But if you make contact, the hand will bounce off. If you don't know how to contact, you don't solve the contact problem. So we need to go back to the old problem 300 years ago and solve this contact problem. Okay, that will bring robotics start to look like into science. Okay, also we are bringing sports into science. We show people the secret consistency in sports. You know, secret consistency in sports is prolonged contact, and that will make the contact time a little bit longer so the player can guide the ball. All the professional player knows this. Okay, they're practicing this. Okay, this is in practice, not just a theory. Let's say. So we need to solve this problem, the 25 variable problem of contact. Today's scientists can only handle 10 variable problem. They can only most problem are 5 variable. A Nobel Prize winner will be able to handle 5 variables, one old, one new. Okay, above 10 variables, nobody can handle. Dai Wu is one of the person who can think this problem of contact. And if you want to go into software, then that's 500 variables. But if we can solve the software problem, then we have a situation where all human beings over the age of 6 can start to contribute, can write software, start to contribute to knowledge. Okay, that's a big jump, but it's the problem. The complete automated software is a difficulty. That's really innovation, and also this genetic programming, all this stuff. You know, they try to do this. You know, we already solved it. We identify DNA as a complete automated software. So we are the person who, we don't need people do experiment to find the helical. We solving the problem of complete automated software is the theoretical discovery of DNA. Okay, so you know, this is, I think it's more difficult. The easy problem to solve is the contact problem, which has been with us for 300 years. Okay, the society need to put their resource to solve this easiest of all the post-science problems.
Thank you.
We cannot